It's 3 o'clock. Hello, R. We don't know your full name, but we see that you're here. Hello, Justin. Thanks for being here. Fabian, always good to see you. Dr. Carter, thanks for being on. Rest of the team, thanks for being on. So it's 3 o'clock. We'll go let some people join late if they need to, but might as well go ahead and get started. So, Melissa, you want to tell everybody what we're up to?
Sure. Hi, everybody. I'm Melissa. Thanks for being here. We're going to take a short. We're going to have a short 25-minute talk. We'll be recording it, and we'll replay it. Hey, Lester, you want to take over?
Sure, yeah. So thanks, Melissa. It's a 25-minute talk. And what the talk's going to be about is the situation we've gotten ourselves into as Americans by not generating enough energy over the course of the last few decades, right at the time when we need to plug a lot of stuff into the grid. What that's going to mean for all of us, the solutions we believe that can solve the problem, and then really want to encourage y'all to ask as many questions as you possibly can, specifically because it's being recorded and you're not the only people who will have those questions. There are no dumb questions when it comes to unfamiliar information, and we welcome those. Afterwards, we'll invite you to participate in what we're doing if you think our solution set will be successful. We do. That's why we're all here. And one of the biggest reasons that we think it'll be successful is because we have tremendous leadership. The man I'm going to introduce next, I've known since he was an 18-year-old kid. He has exhibited outlier performance in every endeavor he's ever encountered, and he's only encountered very challenging endeavors. So when he heard about the national energy emergency, it was just sort of a natural fit to believe that he might be able to do something about it, especially with a capable team supporting him. So I don't know that we're a capable team, but I know that we're fortunate to have John Kerry on the human team and on the American team during this national energy emergency. So with no further ado, CEO of Ovanova Energy, Mr. John Kerry.
Thanks, Lester. Grace, if you wouldn't mind pulling up that slide deck, I would be grateful. And thank you guys for coming. We are intimately familiar with the value of time. And thank you for using some of yours to come here and join us. Again, happy to take questions at the end, but I actually would appreciate any pauses in this to ask a very specific question while it has context. I'm gonna spend it half of the time that we have together diving in this kind of the nerdy aspects of our electric grid, how we became aware of those challenges, and what we decided to do about them. So there's a hand down there at the bottom. It looks like, it looks like this. If you look kind of a couple buttons over from the red hang up button, don't hit the red hang up button. But just, I'm curious, by a show of hands, who here knew before this meeting, before this slide, that we were in a national energy emergency? Nice. So we had a bunch of people raising their hands. I should have said, no Ovanovans. You guys are intimately familiar with that. But okay, so when I think national energy emergency, I think a whole lot of things, but that's because as a team, we've spent the last 10 years in energy. And what I've found is that it doesn't mean a whole lot to people when I tell them that we're in a national energy emergency. So I'm going to take a moment here and explain a few issues that I'm aware of. And then maybe you guys have some knowledge about what's going on that I don't mention. And I'd love to hear from you in that regard. So you can look at this little, I'm not sure if you can see my pointer, but there's a graph there where it says electricity generation at the top. It shows that red line is China's electricity generation, kind of a very linear, keeps going up, doesn't stop going up, except for maybe somewhere around 2014. But you can see the US, we've pretty much flatlined over the last 2.5 decades. And the whole time that's been going on, we've been plugging more things into the US grid. So, we've got Bitcoin mining. That's heavily electricity reliant. We've got EVs, and those are going up. Those are becoming more and more and more common. electrifying our homes and businesses. I believe that in California, you can't even build a new home with gas appliances. Everything's electric. AI, that's a big topic. Some of the leaders in the AI space are projecting that 99% of the electricity that we generate is going to be used by AI. There's data centers going in that just the data center itself uses as much electricity as New York City does. And we're hoping to onshore manufacturing, and manufacturing facilities use a ton of electricity. So while we haven't been generating more electricity, we've been finding more excuses to use electricity. And so if that's not enough, we've built a whole new problem set in the last 10 or 15 years that our grid operators have not dealt with, which is that last little rectangle on the bottom right, the solar and the wind farms. So again, my goal here, I'm really just hoping to help bring to your attention that our utility companies have a massive, massive job to do. And every time we add solar and wind to the grid, it makes that job harder. Why is that? Well, because in the past, with a hydroelectric facility or a nuclear power plant or a coal facility, we can produce stable power, reliable power. Whereas with wind and solar, the wind's not always blowing, the sun's not always shining, and it's not just, it's actually a little bit more abrupt than that as well. You can have a beautiful sunny day with a huge solar field supporting the big city of Los Angeles, and then all of a sudden a cloud comes over and you go from 250 megawatts to 20 megawatts. And so this intermittency not lining up with our demand as a human family creates problems that our grid has not faced before. I'll give you a couple other examples. This is regularly occurring right now on the US grid. And the statistics are showing the amount of times that what I'm about to describe is happening is actually going up and up pretty quickly. So in the same day, utility companies will actually pay money to people who solar farm and wind farm, people that own big electricity generation facilities that have wind and solar, to disconnect their power plants from the electric grid. Anybody know why they would do that? It's more fun if people interact, but you don't have to. Anybody have a guess why we might pay people to stop producing electricity? It's because
Like a war, like an attack.
That's definitely possible. The main engineering reason is it's during a time when people aren't using enough electricity, and so we don't have anywhere for it to go. There's not enough storage to send it to, and so therefore it's cheaper to pay a solar and wind farmer to stop producing so we don't over voltage the lines than it would be to try to spin down a hydroelectric facility or a nuclear power plant. Those things are big old behemoths, and they just do the thing consistently, right? So that's the best strategy we have today. And the amount of money and the amount of time that we're paying to disable those power plants is actually going up and up. And then in the same day where we paid people to not produce because there was too much power, when people start to get home, plug in their electric vehicles, cook, turn lights on, we actually encounter this time called a peak period where we're not producing enough electricity to meet the need. And so there's all sorts of mitigation strategies that utility companies deploy, like paying manufacturers to run on their generator and disconnect from the grid so they can relieve some stress on the grid. So they'll pay for that generator fuel and that generator maintenance. They will give discounts for customers on their bill to be able to remotely shut off their air conditioners and hot water heaters. So in the same day, utility companies are paying because there's too much, paying because there's not enough, and there's a whole other myriad of problems we haven't even talked about yet. All the while, we haven't even started to deploy these AI data centers. EVs are just now starting to become something that people are like, whoa, these things are fun. These things don't have any oil changes. They don't have any brake jobs. They don't have any antifreeze. Like these are, you know, I want one of those. They run on free sunshine. Instead of ever having to stop at a gas station, my gas station can be the roof of my home or my business. These things are becoming more and more apparent to people, and the transition is happening more and more frequently, and this is putting more and more stress on the grid. And so we are in a national energy emergency. This is true. These problems are solvable, but they're not solvable through centralized power. And the reason that's the case is because of the way we've developed our grid over time. Consider this. We have a utility company that has a big nuclear power plant. We have these long transmission lines that distribute the energy to what substations, where the voltage is dropped down to a more manageable voltage for distribution lines. Those power lines you typically see outside your neighborhoods and things like that. Well, when we send a set of power lines out from a substation, we as humans just keep building stuff. That's just what we do, right? We build a neighborhood, and then we build a school, and then we build another neighborhood, and eventually that circuit coming from that substation is kind of like an experience that many of you may have had in your homes, where you might have been toasting some bread in the morning and you got the coffee going on, and then somebody pops something in the microwave and the breaker pops. Maybe you've experienced that, maybe you haven't, but that's a circuit from your electrical panel that's overburdened. Now, there's a couple things you could do about that. You could just be okay with it and just reset the breaker every time it happens. You could know not to turn your coffee pot on until the microwave is done. You can, that's those strategies that the utility company does, where they know that the breaker's going to pop. So they've already got agreements with the manufacturer to say, hey, the breaker's about to pop. Why don't you run on your generator right now, right? So you can do it that way. What's about to have to happen all over the country is that we're going to have to pay for grid infrastructure upgrades, and that would be the equivalent of saying, all right, I'm going to hire an electrician to put another breaker in my electrical panel and run a new wire to my kitchen, and I'm going to plug my microwave into that, so that way that doesn't happen again. And so we really don't have the time or the resources to be able to upgrade our entire grid to be able to meet the electrical needs that are coming. And so therefore, the solution is going to be little power plants everywhere. And you can go to the next slide. I'm actually let Lester, we'll go back to this one in just a moment so you guys can really get a good idea of why we know this stuff. So these little power plants everywhere are the solution, because we can co-locate the electricity generation right where the electricity is being consumed. So just imagine not paying the electrician to put another circuit in your electrical panel, but putting a little power generation source in between the coffee pot and the microwave. And whenever the microwave is about to get used, that generation source discharges power into that line, so there's plenty of extra bandwidth on the circuit, no infrastructure upgrades needed. Right? So this is the idea of distributed energy resources, or little power plants, working together in what's called a virtual power plant. You use software, smart controls, solar and batteries to be able to work in a symphony with traditional grid resources to keep the grid reliable and safe, and to keep us from investing millions of dollars on infrastructure upgrades that just aren't necessary if we use the technology that's available today. Now, we'll talk a little bit about how that's a terrible idea to put 100 million power plants up on the US grid if they don't have, if they're not cyber secure, because they're going to be used to support the grid during its peak times. And if they don't behave properly, they could shut the grid down, and that's not a great thing. But that's why I'm going to introduce Lester for a moment to help you guys understand our path to competency, our path to understanding these things, and our path to actually having the solutions today to be able to deploy that. And many of you came here because of our portable energy technology. You guys supported us on WeFunder. You saw we're building 30 pets right now to get them deployed into the wild to show the world what's possible with these mobile microgrids. And we wanted today to unveil the real strategy behind pets. It's cool to have a mobile microgrid. It's great for disaster relief, but it's got a deeper piece in the puzzle that we'd like to help you guys understand today. But for the moment, just a little bit of background on us and our journey over the last 10 years in energy to going from a solar sales company to America's energy team that doesn't disappoint. So Lester, tell them about Ovanova.
Yeah, man. About 10 years ago, we thought, go back up to the slide, the one that's got the 3 companies on it, Grace.
There we go.
There you go. So a decade ago, we were in LA and we had the opportunity to get into solar, and we saw that it cost way too much for people to want to buy it. And we thought, why is that? And we were taught by our mentors that when trust is high, the cost of doing business is low. When trust is low, the cost of doing business is high. So if it costs a lot of money for someone to adopt solar, it meant trust was low. And so we took it upon ourselves to figure out how to develop trust in the industry. And we did that by working with nonprofits, churches, schools, little league sports teams, cheerleading teams, with a give first, tell the truth model, where we would partner with these organizations and make a donation to an organization they trusted and supported just for showing up to learn about solar. And that worked so well that we ended up with projects in 28 different US states. Through that process of interconnecting with over 60 different utility companies, we learned that one of the things that was holding solar adoption back, other than customer acquisition cost, was a poor experience when it came to actually constructing the project. So in 2021, we took it upon ourselves to start a construction company so that we could maintain trust with the organizations who trusted us with their supporters, sending them to us to become educated about solar energy. Because of that choice, we then controlled which technology we worked with, and we're the first company in America to stop offering solar unless it came with batteries, because we recognized the grid impact, because we were working in areas where the incentives didn't make sense unless someone had a battery. And that led us down a very strange path, because we were the first company to actually install this piece of technology from China called a bidirectional hybrid inverter charger that actually makes batteries work well. We also experienced at John's house, where we deployed this, something that other people didn't have a chance to experience, which is having their lights turned out from China. So at first we thought, this is kind of annoying. We don't want our customers' power getting shut out without an announcement for a firmware update. And then we thought, oh my gosh, someone abroad just affected the US grid by turning the power out. And if there were 100 million of these little power plants, which is exactly what we need to solve our national energy emergency, we would be in some great trouble if we didn't take care of that right away and do what we could. So we started working with government agencies, started working with Department of Defense contractors, and ultimately just took it into our own hands. But Ovanova Energy is a hardware and software manufacturing company. One of the pieces of hardware is pets. One of the pieces of hardware is secure communications. One of the pieces of hardware is a national energy resilience device that's a US-made hybrid bidirectional inverter charger. And because of that technology, there are software implications as well. But to talk you through what we did after we found out that it was possible to control power electronics from a different country connected to the US grid, I'll flip it back to John to share with you the solutions that we've created to make distributed energy resources accessible, affordable, and secure.
I see those questions are, and I will love to get to those or not. super connected to the conversation that we're about to wrap up. So we'll get to questions in a moment, but thank you for questions. We love them. So just to be clear, that journey, it's all because we love you. We wanted people to access solar. We saw it was too expensive. And then if we were doing it for our moms and our mom got a leaky roof and we couldn't go up and get it fixed for her quickly, then we didn't feel like that was a good way to be. So that's why we became unlimited general and electrical contractors. We've designed, developed, deployed, and maximized power plants in 28 states so far. We even have a few in Kenya. So it's been a fun journey, but it's all been in an attempt to continually offer a high quality service to our customers and actually be able to accept full responsibility for the power plants that we create. And we accept responsibility for 2 decades at a minimum. That's just where we start with people. If anything, we'd really say it'd be forever, right? But you know, the world that we live in requires us to say 20 years right now. What we're getting at here to kind of get back into it is if you could go, Grace, if you could go to the orange slides, it's just to click a few more times, just for the sake of having a visual. There we go. So what we had to do is we actually had to work with cybersecurity experts. We've been awarded 9 CVEs by the U.S. government, common vulnerability and exposure numbers. We've identified 9 vulnerabilities that our U.S. government was not familiar with, and they're now aware of them. And you probably have seen, if you're paying attention to the news in the past few months, a lot of cybersecurity talk when it comes to energy. The grid has tons of cybersecurity, but when you go on the customer side of that meter that you have, if you're as a customer, there is no cybersecurity regulations associated with the stuff on the customer side of the meter, which is where all the little power plants that we deploy are located. So therefore, it's looked at like a refrigerator, just like an appliance. And so therefore, it hasn't been scrutinized deeply. Well, we've scrutinized it deeply, and we've also come up with a prototype that works today that securely encrypts any incoming and outgoing data. So unless you know the secret handshake, you're not going to be able to speak to or understand what our inverter is doing. And we've also got a functional software that allows utility companies to use these little power plants in a sophisticated way to be able to support the grid. So currently, the best we're doing in the country is using, it'd be the equivalent of using your smartphone as an alarm clock, right? Something that's really kind of it does way more than that, but we're just using it for an alarm clock. Well, that's how little power plants are being used today. We're basically saying, we think tomorrow between 3 o'clock and 5 o'clock, it's going to be a peak time. So please program your inverters to discharge their batteries during those times. It's a very lucrative business. Just to give you an example, if you live in Texas, you might get paid $4 or $5 per kilowatt hour a few times during the summer to discharge your batteries, when the utility company normally charges 14 or 15 cents a kilowatt hour. There's a huge energy arbitrage opportunity there. One of our pets, if you've been paying attention to our WeFunder, if you park that up at a house in Connecticut, connected to Eversource, working on their virtual power plant programs with Energy Hub, it might make you 10 grand a year just sitting there participating in 50 to 90 events. So there's this very, very big market for just pumping energy into the grid during time range, when in actuality, electricity is much more, it responds immediately. And it's one of those things where we really need to be, instead of pushing and pulling energy into the grid, we need to be engaging with it in a much more orchestrated and smart way. And that's what our software is doing now. We're working with Amazon Web Services through one of their contractors called Commit for over a year now. So these solutions for hardware and software all come together in a culmination with these pets. And most of you guys are here because of pets. And so here's what's going on. And I'll kind of wrap this up. We've done it. We've talked about a lot, and then we'll let questions fill in the rest. So where, like Connecticut, California, Texas, there's a lot of solar penetration. So utility companies already know that little power plants are beneficial. They already have created these incentive programs that are causing people to buy little power plants, because not only does it get rid of their never-ending, always escalating electricity bill, right? It's like, why in the world would you rent something that you're going to use for the rest of your life, like electricity? It only makes sense to own that. Well, people are having even more an incentive than just renting versus owning, because now they're getting paid when they produce extra electricity at the right times. But in the deep country, you don't have a lot of solar. Those rural electric cooperatives, they don't really have any experience with little power plants. So that's what these pets are going to allow us to do. Most of our work over the last 2 decades has been serving farmers and rural business, last 2 years has been serving farmers and rural business owners. And we've learned that these rural electric cooperatives, we've oftentimes had to help them write the interconnection document, because it's the first time that they've had solar connected to their grid. So they definitely don't have sophisticated incentives to have people with little power plants get paid to help out during those peak times, even though those are the people that need it the most, right? The grid edge communities, the people at the very end of the line, right? The ones where we keep building onto it and building onto it and building onto it. That's where they need this stuff the most. So we're going to take our software, which we're already acquiring customers today because of our pilot project conversations. I call a rural electric cooperative. I have a Google Meet with them. I ask them where it hurts the most on their distribution network. And the people that are stressing them out the most during those peak times are the ones that we're building microgrids for. But in the meantime, we're going to be able to take 20 or 30 pets, take them out to a rural electric cooperative, park them on that distribution line that's the most overburdened, and give them the controls to our software to show them the value of these little power plants. I can't make the church and the school go solar way out in the country, but I can show the utility company how valuable it would be if they did. And then I can co-create those pilot programs with them and then deliver that stuff to that local community so they have a good reason to take action, right? And this is how we solve the national energy emergency. Many hands make light work. Little power plants all over the place. They need to be secure. If they're not secure, they're not scalable. They need to be distributed in the right places, and they need to take action at the right time and in the right way. So that's kind of the chess match, right? We set out on our mission to add as much value as possible to as many lives as possible as soon as possible. That mission led us to energy. We were convinced that the more access that the human family has had to energy, the better the world has become for all of us. We saw solar energy as a place to start. We saw soft costs for making it too expensive. We saw project management and construction, even if it was inexpensive, we're holding people back from having an amazing experience. And then we saw the need to babysit those power plants to make sure that they were monitored and maximized for the owner of the power plant. And throughout the process, we unraveled a deep respect for what our utility companies are doing and the problem set that they're facing. And that's where all the solutions that you guys have heard today have come from. Yes, pets will be awesome when you have a pet locator app and you can say, I'm about to get married this weekend and I don't want a loud generator. I want to look where the closest pet is and I want to rent that. Yes, pets will be awesome for disaster relief situations, for sure. Yes, pets will be awesome when Burning Man happens and we can call 1,500 pets to Burning Man to help run the show out there. But in general, short term, it's part of a big picture to help solve the national energy emergency here in America. So I'm going to pause here, open this up for questions right after I let Lester fill in any gaps that I might have left out. I might have said some things that didn't connect. I don't know what I don't know. So.
Yeah, I have nothing to add to that and would like to turn it over to questions from the crowd. And I'm going to start by dropping a link in here to the study that John referenced. You asked about Sandia. The report from our cybersecurity study was actually presented at DEF CON 33, which you may or may not be familiar with, but it's basically the Super Bowl of cybersecurity, Black Hat DEF CON conference. So that's a link to the study. And you're welcome to go on the DEF CON website to confirm what I said. BC Security is a cybersecurity firm that confirmed what we were doing. One thing that John said that might not have been clear was that the 9 CVEs basically when we found these cybersecurity vulnerabilities, we could have sold them to Russia, we could have sold them to North Korea, but we reported them to the government and we started working on solutions for them. And that's what we have created today is actual solutions that will allow distributed energy resources to scale, because if it's not secure, it's not scalable. So happy to answer any questions for the crowd along with John.
Thank you, John Lester. That was insightful. We appreciate that. Thanks for giving us an inside look at what's happening across Ovanova and what's next. So let's move into question and answer. We've had questions start pouring in during the presentation, which is great because that means people are listening and engaged. So now we'd love to hear from the rest of the audience here. But before we get to the rest, R has one more question that I feel like hasn't been answered yet. So the other question from R is, who is managing the service and warranty of the systems sold across the 26 states? It's actually 28.
John answered it, but he might not have heard it. We do, R.
Yep. And Abud is on, and he's one of our plant doctors. So we have been developing anomaly detection in the software that is actually paying attention to the power plants to determine if string voltages drop below X value on a sunny day, et cetera. But we also are, because we're developing that software, still have real human eyes on it. So Abud, would you mind just sharing with the crew, like when you're reviewing power plants and monitoring them, like what things are you looking for? Tell us about some maybe recent challenges that you've run across. Like what kind of stuff happens to a power plant that you get alerted to? Just what do you do as a plant doctor so people know that people are watching?
Yeah, thanks, John. Wasn't expecting to take any time today, but yeah. So basically my work as a plant doctor is to babysit those plants, as John said, to make sure that the plant that we told the customer this is what your plant will do is doing exactly that. Every day checking those three things, checking ensuring that the batteries are discharging when they should be and they are being maximized. What else? A lot of things, but basically that. Thanks.
What are your credentials, Abud? You're a highly you're an overqualified babysitter. What are your credentials?
Oh yeah, I'm a trained electrical electronics engineer, solar design engineer, and adding that the plant doctoring that I've trained very highly here at Ovanova. Thanks.
Thank you, Abud. So any more questions about how that works? Happy to go into as much detail as you like, but we take care of that. We accept responsibility for it all.
Okay, and we have another question in the chat dropped by Peter. Before I read that question, so if you guys have any very hot burning questions, you can use the raise hand feature, or you can drop them in the chat like everybody else, and then we'll read it for you. So here's the one from Peter. How does the upcoming change in the investment tax credit affect the value proposition of Ovanova plants going forward?
Let me do that one, or you want to?
Sure, yeah, you go for it. I just want to say hey to Peter Thomas. Thanks for coming.
Speaking of EverSource,
Yeah.
So, hey, Peter, good to see you. The only thing that really changed with the ITC was that if you were a residential homeowner deploying a power plant that you own, the ITC ends in December. All of the other parts of the ITC remains the same. So for Ovanova, because we've shifted more to businesses, and because we're capable of creating leases to still offer to homeowners, the only significant change is that the ITC is slated now to end in 2027, except for battery systems, which the ITC was not affected at all and still runs through 2032. So if anything, the proficiency that we've gained in deploying battery systems puts us way ahead of the curve and puts us in a really good position. The significant changes in the equipment that we'll be able to use. In order to claim the ITC, a certain percentage cannot come from China, cannot come from Russia, cannot come from North Korea, but North Korea and Russia don't really make a lot of solar equipment. China makes the best solar equipment in the world. One of the reasons that we started Ovanova Energy was to make some equipment in America. But we have ways to meet the requirement so that our customers will still be able to qualify for the ITC, the bonus ITC, as well as the transferability of tax credits, which makes it super affordable from a cash flow perspective for a business to access our technology. That's a really good question. If you have any more, happy to go into that. But luckily for us, because of the moves that we've made over the last decade, it affects us far less than companies who were just selling solar without batteries and relying on cheap Chinese equipment to do it. And the good news is there is some stuff that is coming online this year and early next year made in America. So
Thank you, Lester. Now, someone sent me their question. I'm honored to ask this in your behalf. So here's the question. What are the main risks you foresee in developing the pets, and how are you mitigating them?
Not being able to make enough fast enough is one thing. How are we mitigating that, John?
So one way we're mitigating that is by, so this also goes hand in hand with R's question earlier about who's going to be servicing these power plants. Well, what we've learned to do is to not work with solar companies, but to work with local electricians and roofers. And we just had Eric Campbell jump on. I don't know if he's actually still here, but he's one of our most recent residential installs. And while we sent Ovanova microgrid technicians, we sent our microgrid technician to join a bunch of local contractors, and one of which is pretty much as good as an Ovanova microgrid technician as an independent contractor now. So we upskill local people because we know that if there's a problem with the power plant, it's people's energy. And we got to get that stuff functioning ASAP. And that means that there's no time for somebody to take a flight. So we've made really good connections in local communities by treating contractors right and by teaching them what we know so they can do it without us. And therefore, it brings us new customers, but it also creates people like Bobby McLaughlin from 4 Elements Electric in Virginia, who has done multiple installs with us, is a good friend, and he is itching to build pets with him and his guys. They're actually looking at building a facility right now to be able to exclusively build pets, making it big enough to build multiple at the same time. And we've got a situation like that in multiple locations around the US. We need many more, but it's a recognition that once you've made a mobile microgrid, you gotta deliver it. And so if we can make them all over the place, then our delivery distances can be much shorter, which will allow us to deploy them at scale a lot easier. I don't know if that was what you were going for, Lester, but
yeah, and we're developing the first accredited microgrid technician program in America as well. So people will find us.
And while let's read, thanks for the, what are Ovanova advantages compared to larger companies already established in the DER space? Might be webinar. Yeah, Lester, I'm gonna let you chew on that one while I just mention one more point about some scalability issues. So we're often doing things that haven't been done before. That's just like that, and that might actually go along with your recent question, R, which was like, what makes us, what are our advantages? Well, like, we do things that other people just haven't done yet, and that can also be a challenge. And so these mobile microgrids they can back up facilities. In order to do that, they need to be plugged into facilities. And I imagine that we're going to run into inspectors in some places that are that just haven't seen a trailer with a real power plant in it running a building. And so while everything meets the National Electric Code, it's a little bit weird to see 2 big extension cords coming out of a trailer plugged into a building. And there might be some, trepidation associated with safety. Like we might end up having to like install bollards or kind of like concrete walls so we can make sure that nobody's running over them. And so we just haven't run into a whole lot of different authorities that have jurisdiction over rule sets like this. And so I imagine it will be I imagine it will get a lot of grace because we're going to be in rural areas, in communities, and these things are going to be parked at churches, schools, fire stations, police stations, these epicenters in communities where they support the actual community around them, right? If your police station, your fire station, your schools and churches all have lights on after a disaster, they all have internet access and communication, that's transformational to the community. So I imagine we're going to get, I imagine we're gonna get a lot of grace, but we just haven't run into those scenarios yet, and I foresee that being dramatic in certain instances, especially out in California. What was Eric's question?
Well, I think to speak more to what Art said about some more advantages that we have before we get to Eric's question. One is we got to this place by actually installing and paying very close attention to what was going on. Most established DER companies they're looking to sign up other solar companies' customers without recognizing, one, there's not a lot of storage. Two, the type of storage that is there is limited. And I'll give you an example. Octopus Energy, which is a huge billion-dollar DER situation, as of a year ago, wasn't able to control the equipment that was the most able to have the highest impact and create the highest value for its owner. They were just able to control smaller, less able power plants, but the biggest thing is that they depend on other people's customers and other companies not willing to go all the way in order to gobble up these resources. John's mentioned 2 or 3 times, we work in rural America predominantly, where there is only a 5% DER penetration with the local power companies. So it's a blue sky type opportunity to do it the right way from the beginning. Our software can also control other solar companies' equipment for stranded customers who aren't plugged into the DR future. But one of the biggest things that give us an advantage is where we operate and being able to set the precedent from the beginning and being able to control any type of equipment from the beginning. And most importantly, with our power plants, to do it securely. Because a distributed energy resource that is not secure is not a resource, it is a threat. So those are some of the advantages that we have in what we're doing, that we get to field test it on our own projects, get the data, make it better. We're not waiting for other people's customers to come to us, although they will. And then Eric asked, can you hook up a Tesla car to one as another power source? What a great question.
You've got the technology that's in our pets at your place. Have you tried doing it yet? You should know the answer to that question, Eric. I don't know if you were asking it for our benefit or you were actually.
I didn't know if you're utilizing the same technology on those as you put here. Yeah.
Okay. Well, hey, good to see you, and thanks for coming, Eric.
Yeah. Sorry I was late, but yeah, I can backfeed into our grid here.
Yeah. Yeah. So not every pet has that technology. We have a 3-phase pet that does not, but our single-phase pets do, and yes, exactly. So I'm glad. I believe Chris showed you how to do it, but let us know if you have any questions. And I believe you're fully selling back to the grid now, aren't you?
Yeah, every day.
Yeah, man. Congratulations.
Nice. You just announced another double-digit increase this year. So, yeah.
Little power plants give you a forever stamp on your electricity costs. Mm-hmm. Sunshine's free. You own the equipment. All these electricity rate hikes, not going to impact Eric.
Right. So these portable solutions you guys are talking about here, what's the rough cost on one, and what's like the how many kilowatt hours of batteries would be on one of these?
The what solutions? I didn't catch the first part.
Aren't you guys talking about the portable solutions here?
Oh, portable solutions. Yes.
Yeah.
Maybe, I don't know if you guys are open to it, but Grace, if we could play the 4 pets that we already, if we could play that video, that'll answer Eric's question and also show our team's ability to produce with what you guys have given us so far. That's exactly what this We Funder Money is for, guys, is to build these pets. And that's exactly what we've been doing. Can we play that video? Por favor. Pretty please. Yeah, you might be taking her time. Abud's got his hand raised in the meantime.
Yeah, just quickly now. So one of the things that we do so proudly at Ovanova is to make sure that all these power plants are well managed, they're operating well, and looking at the way we plan to scale these pets as they come up. When we have hundreds of thousands of these, we're also thinking about scaling in the maintenance and the control and the power plant doctoring. Are we also equipping our the people who are building the pets with us so that they can also be managing and the power plant doctoring the pets? Or how are we going about that as we scale? Thanks.
Each one teach one. We don't just keep all of our knowledge to ourselves. We've built cookbooks and recipes to be able to design power plants, to be able to deploy power plants, and to be able to babysit power plants. And all of that stuff is open source to you guys. We need as many people as possible affecting these solutions as quickly as possible. Go for it, Grace. Thank you, Abud. Very valuable insight.
Have you ever lost power at the worst possible time? But you didn't even care because you had a complete microgrid parked in your driveway? That is the Ovanova Pet. This is our line of portable energy technology. These are our portable energy trailers. So follow me, let's talk about each of them. This is our Spark, the baby of the bunch. This model has 1.29 kilowatts of solar. It also has 32 kilowatt hours of battery, 11 kilowatts of AC output capacity, and it comes with a 120 volt portable generator just to recharge just in case. You can see it's a 5x8 trailer, small, compact form factor, space for extra materials, maybe tourniquets, maybe fuel, maybe water. It's got the ability to plug into the grid, to charge, to wire into a building, to feed it, to plug 120 volt and 240 volt power into it to run extension cords wherever you need. And it is towable by an SUV. You can see plenty of room inside for extra equipment without overloading the weight capacity and without making it too challenging to tow. Small form factor, very maneuverable. Let's go check out a bigger trailer, the Ember. This trailer is a 6x12, which means it's still very maneuverable, but this trailer has big power in a small form factor. 22.8 kilowatts of continuous AC inverter power, 64 kilowatt hours of battery storage, 2 bidirectional EV chargers, and you can see the propane plumbing for an onboard DC generator. So this thing has solar, batteries, can draw power from electric vehicles or charge electric vehicles, plug into the grid and charge, wire into a building. If you're taking it to a lot of parking lots, job sites, tight space in your driveway, no problem. Big things, small packages. Now let's go look at the same equipment in an even bigger form factor. The Flame. This is our flagship 120 240 volt model. The advantage of the bigger trailer, this is a 7x18, is that there's even more solar. We have 6 modules on the awnings, we have 6 modules on the roof, so we're enhancing our off-grid capacity and we're enhancing our ability to refuel. But you can see same 11.4 times 2, that's 22.8 kilowatt AC inverters, 2 bidirectional EV whips, 64 kilowatt hours of storage, and a whole home backup generator that is DC coupled. That's designed to turn on whenever the batteries get low, meaning that as long as you have a little bit of sunshine, the grid, this generator, fuel for your generator is propane, which is easy to acquire, or an EV to plug in, this will have power. And moving on to our most powerful unit yet, the Blaze. Same great form factor as the Flame, 6 solar panels on the awnings, 6 on the roof, same easy single phase integration, on grid, off grid, no problem. What's different about the Blaze? The Blaze is 3-phase, so you can charge this up from a standard home or business 1450 outlet, and you can provide three-phase power during an outage, or just not during an outage because you don't have three-phase power and you need it for something on site. So it's our most powerful yet. We've upgraded the axles so we could stuff more batteries and more inverters and make this a real power trailer. Each one of these trailers comes with our secure encrypted communication system. You can see that black and green box on the wall. There's a corresponding antenna on the front because we know that in a disaster, communication is non-optional. So all of our units have a Starlink on the roof and secure encrypted communications. Not only does it let these inverters and electrical systems operate safely without interference from bad actors, but it lets us have capabilities to set up communication systems in disaster zones. So if you're first responders, police, healthcare workers, etc., there's a way to communicate and coordinate a disaster relief effort, but also to let people communicate to their loved ones and charge their phones and provide safe, reliable power to a community building. We are building America's energy future one pet at a time, and you can be part of the solution. And that's what the pet allows you to do, is become a community hero, provide your own reliable power, and rent that sucker out and make it pay for itself. Let's get some pets out in the world. Do you like what you saw? Follow along as we build out the blaze, deploy our pets, continuously iterate, partner with people doing good in the world with our pets. And if you didn't like these pets, then I will be emotionally crushed, and just let me know what I can do to build better pets for you, and I will adapt myself in any way possible. I will become who you think that you need right now. I will sacrifice my basic identity.
So I saw some more questions, but I think we are definitely going to do another webinar. We intend on doing one in the near future. And if you guys have ideas about what you'd like to hear about, please put them in the chat. We're absolutely a transparent organization. We want you guys, I wish I could download everything that we know into everybody here so we could go and work on this stuff together, because we are in a national energy emergency, but we're not the only ones. There's still people in the world that have to walk to the creek for clean water, that read by candlelight. We've got a lot of work to do as a human family, and we're just focused right here at home right now so we can take everybody here and go focus in the areas that we need to focus in afterwards. So thank you for being here. Thank you for supporting us. And please put your comments in the chat about things that you'd like to see at the next webinar.
Yes, thanks for saying that, John. So the chat is open for any requests on topics that you would like to hear and talk about in the next webinar. Thank you to everyone who joined today, and to the team and the investors who continue to believe in this work. So this has been fun and educational. This will definitely not be the last time we host a webinar like this, so watch out for a future announcement. If you haven't already, you can visit our WeFunder page to learn more, invest, or share the campaign with others. I'll drop very useful links in the chat right now. There's our WeFunder link, there's a link to our website, and then a link to a consultation if you would like to. So thanks again for spending time with us today, and we'll see you on the next update. The replay will be sent to everyone via email. Thanks, guys, and enjoy the rest of your Wednesday.